Composite functions, and this is a continuation of chapter 2, functions and transformation. So we should be able to finish chapter 2 in this video. What is a composite function? How do you look at composite function? As the name implies, these are functions that is being put into or applied after another function. So we say that a composite function is a function that is formed when one function is applied in another function. So if we have two functions, for instance, let's say we have two functions. So if I take the two functions that we have, f of x, let's say I have f of x as a function, and then we have another function, g of x. The composite function would be f, we can have f g of x, f g of x. So this is a composite function. So it means that we first apply g, then apply f. So we apply g, then apply f to the result. So this becomes f by g, f dot g of x becomes f, then we have g of x. So this is what we call composite function. Again, f is composed of g of x. So we read it like f is composed of g of x. We can take two functions like f of x. Let's say you have f of x to be equal to 2x plus 1. So this is a function. And we have another function like g of x. So if g of x is equal to x squared, then we can say that fg of x is nothing but f of x squared. So we have our x squared. So this is f of x squared, which is equal to 2. Then we have x squared plus 1. So this would be our composite function. And if we simplify, this becomes 2x squared plus 1. So we will look at this in details. Again, g of x, in this case we can have g f of x. G f of x. G f of x would be g, the function g, being multiplied by the function 2x plus 1, 2x plus 1, such that we are going to have 2x plus 1. So we have 2x plus 1 squared, and this gives you 4x squared. So it becomes 4x squared plus 4x plus 1. So this is a composite function, and it is good to note that in dealing with composite function, f of g of x, so the function f of g of x, so we have this function f, then we have g of x. So the function f g of x is not equal to the function g, then f of x. Right? In most cases, this will not be equal. Just like you have seen the function f g of x, here we get 2x squared. This is not equal to g f of x, which is 4x squared plus 4x plus 4. In most cases, it is rarely to get these functions to be equal in calculations. So we are going to look at various concepts under this particular topic. We look at domain considerations. We look at some exam tasks that is required for Cambridge A Mathematics, and many other quick tips that you need as we dive into these composite functions. So what exactly is a composite function? When you combine two or more functions, as it is indicated, when you combine two or more functions, you will get a composite function. You will get a composite function. When you combine two or more functions, you will get a composite function. So you can consider functions like x squared plus 1. So x is a member of R as a real number, and g of x is x minus 1. Of course, we know that x is a real number. So if we apply functions of f to this set of numbers, we get 2, 5, 10, 17, 26. That if you apply these values that we have, 1, 2, 3, 4, 5, and you apply these functions f to these set numbers, you simply multiply the numbers that we have using the functions, and we are going to see that in calculations. So the composite function g f of x means apply f first followed by g, as I indicated earlier on. Consider the same number set, or like 1 up to 5, and functions f of x equal x squared plus 1 and g of x x minus 1. Let's see, if you apply function g to this set of numbers, what will you get? You apply this number, you will simply get these other numbers, and we will see that in calculations. So the composite function gf of x or fg of x means apply g first followed by f. So this is a concept that you must note. When you have fg of x, apply f first before g. But if we have fg of x, then apply g first before f. So let's see how we can use this function now in calculations. Let's look at the first example. The function f and g are defined as follows. So we have f as a function that maps 3x plus 2, where x is a member of R, meaning that x is a member, they are all real numbers. We also have g as a function that maps x. We have 7 minus x, so this is 7 minus x, right, where x is a member of R. So you are to find a fg of x, fg of x. So this is the first one. B, we are to find f of x, and C, solve the equation g f of x equal to x. So let's start from the first one. The first one, you are to solve fg of x, fg of x, right? So fg of x is nothing but f. Then we have g of x. G of x is given as 7 minus x. So this is 7 minus x, right? And what is our f? It is simply 3, and our x is already 7 minus x, so it is 3, because we have 3x. So we have 3 into 7 minus x then plus 2 that we have outside, plus 2. Open this up, you have 3 times 7. This gives you 20 what? We have 23 minus 3x. Exactly, so this is what we get, because you know that we have 3 times 7, which gives you 21. If you open this up, then 3 times x gives us negative 3x, then minus 2, right? So we have plus 2. 21 plus 2 gives us 23 minus 3x. So now that we have, this is what we need in the first equation to substitute 7 minus x for g of x. B. Question B, you are supposed to find what is f of x, right? F of x. First of all, f of x gives us what? F into f of x is simply 3x plus 2. So we have 3x plus 2, right? So 3x plus 2, when you open this up, what is f? F is 3, so it is 3 into 3x plus 2, right? Then plus 2. This becomes 9x plus 6, right? Then 6 plus 2, 8. So we have 9x plus 8 as the solution for B. And C, we have G. Question C, we have g f of x, the function g f of x. So we apply g first before x. So therefore we are going to have g outside. Then f of x is simply 3x plus 2, right? Then we are going to have 7 minus 3x plus 2 plus 2. So this becomes 5 minus what? 3x. 5 minus 3x. But remember, let's write up here. But remember that g f of x is equal to 2x, right? G f of x is equal to 2x. Is that correct? G f of x is equal to 2x. So if g f of x is equal to 2x as indicated here, then this implies that our 5, we are going to have 5 minus 3, 5 minus 3x that we got here. 5 minus 3x is equal to 2x. Is that okay? If this is equal to 2x, then we have 5 is equal to what? 5 is equal. Let's clean up that. So 5 is equal to, you would simply take 3x to that side. That becomes 5x. Simply take 3x this side and it becomes 5x. Divide both sides by 5. So our x value is equal to 1. Question C solved. And this is how you are supposed to handle this question. Let's look at the next exercise. Look at example number 6. The function f, g, and h are defined by f as a function for x minus 1. G of x is 1 divided by x plus 2, where x is not equal to negative 2. The function h is 2 minus x squared. All are members of real numbers. So we are to find f(g) of x and find h of x. So the first thing that is required of us, right? The first thing that is required of us, A, is to find f(g) of x, right? And f(g) of x is given. We have our f and our g of x. So we will have 1 divided by x plus 2. Right. Divide that by x plus 2. This becomes what? Applying the functions, we are going to have 4 outside. So this becomes 4 into 1 divided by 1 divided by x plus 2, because we know that this function f is 4x minus 1. So we take our 4, multiply by the function g of x, and now subtract this by 1 minus 1. So this becomes, if we simplify, we are going to have 4 minus 1, and then we have the bracket x plus 2, right? Then divide this by x plus 2. X plus 2, such that what you will get, you will see that 2 minus x divided by x plus 2, where x is not equal to negative 2 as indicated earlier on. Because you have 4 minus 1. 4 minus 1 is what? 4 minus 1, you get 3. Right. And then we have our 3. But you have our x. So you will get 2 minus x. The next one is B. We have to find h of x. For us to find h of x, we have the function h into h of x, which is 2 minus x squared. Right. So this becomes 2, right, for h, minus 2 of this squared, then squared, right? Such that we are going to have what? 2 minus 2 squared gives us 4. So this becomes 4 minus 4x plus x squared and all these squared. Such that we are going to have negative 2 plus 4x minus x squared, all these squared. So on the h, you simply subtract from 2 and then you square it after you have simplified, and then you will leave your answer in this form as the required solutions. So you simply have to go back to the original introduction. If you have f g of x, you start with f, then g of x. If you have h of x, you start with the function h, then h of x. And this is what we do in function. Try to solve question number 7, example number 7, and confirm with your answer that I have. I have included exercises that is required for this particular topic, especially in this exercise 2.2, as we move now to inverse of a function. Inverse of a function. Consider the function f of x equal to x squared plus 1. So we have x squared plus 1. If you have x squared plus 1, right? The domain of this function is ranging 1, 2, 3, 4 to 5. The range of this set of numbers is 2, 5, 10. We have 2, 5, 10, 17, 26. 17, 26. The inverse function provides structured evidence that leads to a given result of x. IGCSE concept. It takes you back to year 11 concept mathematics in Cambridge. I want to assume you already did this in year 11. But we are going to look at it again because the inverse function provides structured evidence that leads to a given result of f as a function. The inverse function will be written as f inverse of x. So this is how you write the inverse of a function and map the range. So this function is going to map the range 2, 5, 10, 17, 26. Right. So it mapped that back onto the domain that we have 1, 2, 3, 4, and 5. Inverse of a function. For example, you can look at this function. So we have x, square the number. You add 1 to this function, you get f of x. Later on, it becomes more clear as we dive into recalculations. Because when f of x is equal to x squared plus 1, with the domain already given 1 to 5, the inverse of that function, f inverse of x, becomes root of x minus 1. And we will see. So we can draw the graph of any inverse function by reflecting f of x in the line y-axis. This is the line y-axis. So we are going to see this line y equal x. We are going to reflect. If the line was to go this way, it is the line y equal negative x. So we will look at it graphically and see how we can use this graphical method to solve the inverse of a function. Let's take example on inverse. Function f and g are defined as f of x given as 3. So here we have 3. So we have 3. Need to change the color. So what we have here, we have the function f, which is equal to 3x minus 4, where x is a real number, so x is a member of R. So in this case, we can let f of x, the function f of x, to be equal to y, so that we are able to find what is y. So if we let f of x to be equal to y, we will simply let 3x minus 4 to be equal to y, right? Such that the inverse of this function becomes 3y minus 4 is equal to x. The inverse is the reverse of the function. So we simply reverse this. Instead of 3x minus 4 equal y, we have 3y minus 4 equal x. the inverse of a function. So we change x to y and change y to x. It's just like when you are doing differentiation. You simply interchange. You bring the power down and subtract the power by 1. If it is integration, you simply bring the power down. You simply add the powers and then divide. We'll look at that concept. So here, the inverse of the function would be you try to change x to y and change y to x. So we have 3x minus 4 equal y, and we have 3y minus 4 equal x, such that we are able to solve y to be equal by simplification. Rearranging to get y in terms of x becomes y equal x plus 4 divided by 3, right? X plus 4 divided by 3. So the inverse, f inverse, we are looking for f inverse of x, right? So f inverse of x would be x plus 4 divided by 3, where x is a real number, or simply write x as a member of R. So with correct form, the domain f inverse is the range of f. So this is what is required in this equation. Let's look at B. II, we have II, G inverse. We can solve that up here. So we can let g of x to be equal to y. Let the function g of x be equal y, such that we can now let 1 all over x plus 1 that we have earlier on in g of x to be equal to y, right? Now we change x to y and change y to x, inverse of a function, such that we are going to have 1 all over y plus 1 instead of x plus 1. So this becomes equal to x, right? So solving for y, we are rearranged in order for us to get y in terms of x. So this becomes y is equal to 1 minus x divided by x. Very simple. So g inverse of x would be what? 1 minus x divided by x, where x is a real number, so is a member of R. Remember that x is not equal to 0. X is not equal to 0. Correct. So this is a solution to this second question. B. We are supposed to sketch in a single diagram the graph of y equal f of x and y equal f inverse of x. You want to sketch that? Okay, let's see how we can sketch this. Let's have a Cartesian plane, x and y axis, right? I will show you a clear picture. This is just a sketch, so don't mind my drawing. So we have the graph f of x. Remember, we start with -4. We have -4. So this is our -4. And then -4 along the y-axis, right? So we can draw a straight line graph from this -4 passing the y-axis, and then we join. And then we join from -4 along y-axis and ensure that it has passed and touched the line. So this is our function f of x, and this is our f inverse of x. Again, you can have a dotted line passing through the origin. You can have a dotted line like this passing through the origin that way, and this is a line y equal x. So f inverse of x is the reflection of f of x in the line y equal x. It is a reflection of f of x in that line y equal x. And this is the required solution for this question. Look at the next example. And for clarity, I've included a well-sketched diagram illustrating the relationship between f of x and f inverse of x. So let's look at the next example. Example 9. The function f is defined by f, x squared minus 6x plus 2, 0 less than equal x, less than equal 3 as a domain. Now we are supposed to express f of x in the form x plus a squared plus b. This can be done by completing the square, where a and b are constant. State the range of f. State the domain of f inverse of x. Find an expression for f inverse of x. Express f inverse of x in terms of x, and sketch the same diagram, the graph of y equal f of x and y equal f inverse of x, making clear the relationship between the graphs. So this is what you are required to do. So we are going to start by using the method of completing the square, because you are told to express f of x in terms of x plus a squared plus b. This can only be done by the method of completing the square. So let's see. So we have a x squared minus 6x plus 2. Completing the square. By now we covered completing the square in the first topic where we are dealing on quadratics. You simply take b. B is 6, right? So this is b. B is 6 divided by 2, you get 3. What is the square or root of 3? Square 3, you get 9. So we come x squared minus 6x plus 2 is equal to what? X minus 3, the half of 6, then squared, minus that square root, which is 9, plus what? Plus 2. Correct. Completing the square. Now when you simplify this, you are going to get x minus 3 squared minus what? Minus 9 plus 2 minus 7. Right. Now, when x is equal to 0, f of x is equal to 2. We were told 0 less than equal to x less than equal to 3. So, when x is equal to 0, f of x is equal to 3. F of x is equal to 2, right? Right. And when x is equal to 3, what is f of x? F of x will be equal to negative 7, which is the minimum value. So f of x cannot be less than this. Therefore, the range in B, because we are supposed to find the range, we have expressed, the first one is answered, x plus b squared plus b, x plus a squared plus b. So this is the required solution for A. B, we are looking for range. So the range becomes f, the function f is going to be negative 7 that we have, less than equal to the function f of x. Less than equal to what? So we have negative 7 less than equal to x, f of x less than equal to 2, right? -7 less than equal to f of x less than equal to 2. This is the range. Now, the domain of f inverse is always the same as the range of f. It is always the same. So C, if it is the same, then the domain f inverse of x, f inverse of x is going to be what? -7 less than equal to x, less than equal to x, less than equal to 2. D, find an expression for f inverse of x. For us to find an expression for that, so D, we can solve that here. So we can let y to be equal to x minus 3 squared. But the solution we got by completing the square. X minus 3 squared minus 7, right? Such that x is equal to y minus 3 squared, replacing y minus 7. Then x plus 7 will be equal to what? Y minus 3 squared, right? Y minus 3 squared. Hence, our y will be equal to 3 plus or minus the root of what? X plus 7. Right. However, you should know that f inverse of x must be 1-to-1. We have already talked about types of functions, 1-to-1 function, many-to-one function. So it must be 1-to-1. So we must find whether a negative or positive square root is appropriate. For us to do that, we can take f of 0. If we take f of 0 to be equal to 2, we know that f inverse of 2 will be equal to 0 then. Yeah. This means that we need the negative square root given. So f inverse therefore, f inverse of x will be equal to what? 3 minus the root of x plus 7 instead of plus or minus. So it becomes that, such that minus 7 becomes less than equal to x, less than equal to 2. Less than equal to 2. So that's correct, and that is the required answer to that question. Look at number E. We are here in D. We have solved all these A, B, C, D. Now we are in D, in E. Express f inverse of x in terms of x. Okay, we can do that up here. We want to express f inverse. So f inverse of x in terms of what? In terms of x. So this means that we are going to have f into what we have. It is 3 plus the root of x plus 7. X plus 7, right, such that we are going to have x plus 7. Let me take clear this space. So it is x plus 7 minus 3 squared minus 7. Okay. So now what happens is we are going to simplify this. We have x plus 7 minus 3 squared. We have minus 7. So this becomes root of x plus 7. The root of x plus 7. Root of x plus 7. And we squared this, then minus 7. Minus 7. Squared minus 7. Right. So we are going to have x plus 7 minus 7. And this is equal to x. It is simply rearranging this in order for us to get x, because f inverse of x is always the same as x. So this is the required solution. And finally, we are supposed to sketch on the same diagram the graph of y f of x and f inverse of x. So sketching this graph is simply to draw a straight line, the line y equal x. Y equal x. I can show you that on the next slide so that we can create space. So you have this graph. You try to sketch this graph on this line y equal x. That is the line y equal x. And then you see that f inverse of x is the reflection of f of x in that line y equal x. For more clarity on graphing, check the link below this video. I have included exercise for this particular topic, 2.3, exercise 2.3, and also the solutions for this exercise. Find the answers on the link below this video. Transformations. We look at now translations. Let's look at translations. You can transform the graph of a function by moving it horizontally or vertically. Right. So it is either you move the graph horizontally or you move it vertically. So if we move it horizontally or vertically, that is called translation. It is called translation. Fx plus a will be a horizontal translation of a. That's what we said from the beginning of this video when I introduced the topic functions and translation. Fx plus a is a horizontal shift. Is a horizontal translation of negative a, where negative a can be any number. It can be 4, then it becomes negative 4. It can be 10, then it becomes negative 10. F of x plus a is vertical translation of a. That is to say, if you have f of a value as a function plus 1, it becomes a vertical translation of 1. So this is very important to note. We can write y as a function of x, f of x, and y fx plus 3. So all this will be indicated in this graph. Let's see by example. So example 10, we have f of x to be equal to x cubic, and we have g of x to be equal to 1 over a as a reciprocal function. So you are told to sketch the graph of the functions, marking each sketch where the curve cuts the axis, and state the equation of any asymptotes. 1a, you have f. So here we have f into x minus 2, and we have b to be g of x minus 2. So first we need to sketch the graph of f of x. marking where it crosses the axis. So the graph of f of x, because it is the graph of x cubed, you will get a line. So let's have our line. You will have a graph that looks this way. This is my sketch B. So it looks this way. This is our y-axis and this is our x-axis. And then let's look at the graph of g of x. We have x minus 2. X minus 2, it means it's going to touch. We have 0 and 2, positive 2. So you come down this way and you go up to 2. I will be including steps of graphing these functions on the link below this video, so that you are able to determine the y-intercept and the x-intercept, and from there you are able to graph your functions. So under graphing, you will also check reflection. Then you have some example with exercise that I have included the answers of this exercise on the link. Then you have stretches where you have 2. You simply stretch by 2. That is 2 times 2, 4. So it becomes negative 4. If you have negative 2, we can stretch by 2 to become negative 4. We will do more graphical questions on a specific video that allow us to draw graph stating each vertex accurately. But I will leave with you the link so that you are able to check after sketching your graph to be sure that your answers are correct. So ideally, we have covered several things on this particular topic. We have looked at some terminologies like domain and range, and we have said that if a function maps x onto f of x, then the value of x is the domain of the function, and the corresponding values of f of x will be the range of that functions. And we have defined what is a function. We have also seen one-to-one function and many-to-one functions. We have looked at composite functions, inverse of a functions, and various transformations that allows you to sketch various graphs. And then we look at how we can reflect or transform a graph of a functions by reflecting that graph in one of the axes. And I have shown you how those axes changes, either vertical stretch or horizontal stretch, or shifting or translations, as you will see a little bit better in the link I have left in this video. So this will be the end of chapter 2, Cambridge Peer 1 Mathematics P1. So we are going to chapter 3 now, which will be coordinate geometry. See you there.